So welcome to today's lesson, which is on momentum. So there are three learning objectives for today. Know and use the relationship that momentum equals mass times velocity. Use the conservation of momentum to calculate the mass, velocity or momentum of particular objects. And then also use the relationship that force equals the change in momentum divided by the time taken for that change to occur. So what is momentum? Well, momentum is the mass times the velocity, where mass is measured in kilograms, velocity is measured in meters per second, and momentum, its units are kilograms, meters per second. So just like all vectors, momentum can have a size or magnitude and also a direction, be it north, south, east, west. Okay? And the direction of the momentum is going to be the same direction as the velocity the object is moving in. Just for example, here we have Jonah Lomu in the Rugby World Cup. He has a forward momentum because that's the direction of his velocity. It's forward towards the try line. And because Jonah is about 110 kilos, he has quite a large momentum. So there's also a relationship between force and momentum. A force will cause the velocity of an object to change and therefore its momentum, okay? Because remember, a change of velocity is an acceleration. And the greater that force, therefore the faster the momentum changes, because the faster the acceleration, the faster the change in that velocity. So that's the relationship between momentum, acceleration and force. So if you consider an object which has a mass m, and it's basically changing from one velocity to another velocity over a certain amount of time, then the acceleration will be the velocity change, so the initial velocity minus the final velocity minus the initial velocity over the time it takes for that change to occur. So that's the equation there. So if we multiply both sides of the equation by the mass of that particular object, you get the following equation: ma equals mv minus mu divided by t. Now ma is equal to force from Newton's second law. So the force causing the acceleration, which is the acceleration being the mv minus mu, is equal to the momentum change. Therefore, force equals the mass times the final velocity minus the mass times the initial velocity divided by time. And because of this, force equals the momentum change, okay, so it's the change from when we had the final velocity minus the initial velocity divided by the time it takes for that change. And that force is of course measured in newtons because it's a force. The change in momentum is the same units as momentum, kilogram meters per second, and time of course is measured in seconds. So what does this all mean? Well, it's all around momentum conservation. Okay, so momentum, just like energy, is conserved after any collision or explosion as long as there's no more external forces acting on those objects involved in the collision or the explosion. Okay, so we see this in the visualization here. The initial momentum of the yellow car has been conserved and it's transferred all the way down to the green and the blue car into the red car. And that's known as the conservation of momentum principle.